It's a question of quantity, quantities of gains and losses. So at A, what am I gaining? What am I losing? All right. In order to be balanced, what you're gaining has to be equal to what you're losing. All right. So because basically A in and of itself is valueless. Right. It's only defined by what is coming in and what's coming out. So if there's a flow, then it will have a value. If there is no flow, then it would have no value. Right. So what it's gaining, x1 and x4, has to be equal to what it's losing, x2. For B, what it's gaining, x2, has to be equal to what it's losing, x3 and 100, some arbitrary quantity 100. And at C, what it's gaining, x3 and 80, has to be equal to what it's losing, which is x4. And there is overlap. There's interaction. Otherwise, it wouldn't be a system. It wouldn't be a network. Right? Part of what makes up A is also part of what makes up B and C, and all the other combinations. Okay? So we want to move some things around, but generally, when we think about a linear system, we want to have a standard form. We want to have all our variables on one side and the constants on the other. So for A, this would be the same as, I'll just kind of write it off on the side here, x1 minus x2 plus x4 is equal to 0. B, it would be x2 minus x3 is equal to 100. And for C, x3 minus x4 would be equal to negative 80. All right, so we have variables x1, x2, x3, and x4. And also, just kind of a little bit of a side note, and this isn't anything that we need to look at graphically, but we did learn a lot about 2-space and 3-space, but visually, in a graphical sense. But we don't have a real graphical representation, or at least an accessible one, for free, for 4-space, 5-space, and so on. But this is an example of a kind of problem that would exist in 4-space. It's just not something that we would be looking at graphically. But because we know all the stuff we know about 2-space and 3-space, and we know that it transcends into higher dimensions, we can apply the same concepts to something in 4 dimensions, 5 dimensions, and so on. All right, so just a little context. Fun fact. So for the first equation, I have 1, negative 1. There's no x3, so 0. 4. X4 is a 1. And then 0. 0 x1, 1 x2, negative 1 x3, 0 x4, hundo. 0 x1, 0 x2, 1 x3, negative 1 x4, and negative 80. All right, so we only have the 3 equations. Now, this kind of, was it the first problem we were doing today? Maybe it was the second one, where the question was, or it was related to a column, a leading column containing all zeros. That would be the case in this situation. That would be the case if we had the need to figure out what x1 was, but we had no coefficients for x1. So in which case we would have 0x1, 1x2, 1x, whatever. For each row, it would start off with 0x1, 0x1, and so on, all the way down the line. So that would be a situation contextually where we don't have any information about x1, but we do need to figure out what it is, right? So, explanation 2 hours in the making. honestly, I think, oh, I could stand here staring at it. I'm just thinking it's probably the kind of problem, this is like one exception to all the rules where you could probably figure it out before you even type it in. Little double check action here. And then reduce row echelon. Yeah, that's what I thought. Because all, maybe there's a little bit more to it than that, but it felt like you only had to add like 2 columns or 2 rows. I mean. All right, so again, it's a general flow pattern, so not necessarily expecting complete numerical answers, but we'll see. So I'm going to have x1 equal to 20, x2 minus x4 is equal to 20, x3 minus x4 equal to negative 80. All right, so these two manipulate out. X2 equals 20 plus x4, so it's definitely a dependent system. X3 is equal to negative 80 plus x4. I might as well just write the rest. X1 is equal to 20, and x4 would then be a free variable x4. All right, in parametric form, we'd be looking at x1, 2, 3, 4. We have some constants, 20, 20, negative 80, and 0, plus x4 multiplied by, well, there's no x4 and x1, so 0, 1, 1, 1. All right, so definitely a dependent system, which makes sense because if you're talking about a network, let me just go entire page. Oh, it's too tiny. If you're talking about an entire network, it would make sense that what happens for your input would impact what's going on elsewhere. All right, so it just so happens in this case it's dependent on the flow related to x4, but I could kind of see that. It seems like it's sort of like a bottleneck component where, I mean, there is only one pathway from C to A. I mean, I suppose you could think of these as other pathways, but the flow of it has it going that the only way to go from C, if you're at C, is in the direction of A. Yeah, so I suppose it could be all dependent on that. So if there's a lag here or a bottleneck here, that would slow down everything. But I suppose you can make the claim also for x2, because that seems to be the only path getting you to B. There's other paths out of B. Oh, maybe that's the key. Because there's enough ways to get out of B that it wouldn't slow things up, but there's only one way out of C. But there's also one way out of A, so I don't know. But, I mean, there's no reason to discount it completely as being the dependent variable. the independent variable. The other ones are dependent. Let's actually